Ciao, Codemotion. Thank you so much for coming to this talk today. I have some really exciting things to share with you. But first, I want to start by asking you all a question. How many of you are familiar with Atwood's Law? By a raise of hands. OK, a couple of you, but not many of you. So Atwood's Law, for those of you that don't know, it comes from Jeff Atwood, who's better known online as Coding Horror. And it simply states that any application that can be written in JavaScript will eventually be written in JavaScript. Now, at the time he first made this observation about 11 years ago, it was kind of just a funny observation and didn't really have a whole lot of merit to it. But as years have passed and JavaScript has gotten more and more prevalent and more powerful, it's been remarkably accurate and true. And it's actually one of the reasons why I love JavaScript development and web development, because we build so many different applications, and a lot of them are really cool and really interesting in one way or another. We now build our chat applications using JavaScript as the primary language, our music players, and even our development tools like Visual Studio Code. But we can also recreate old school applications like Winamp and do it completely in the web browser now. And we can also build progressive web applications that enable us to deliver push notifications, serve content offline, and do a lot of other things that used to only be possible with native platform applications. And in particular, these progressive web applications are really exciting to me because they're essentially supercharged web apps. And at the heart of these, they are powered by service workers. And so today, I want to talk about having some fun with service workers and some of the awesome ways that we can use service workers to do things that aren't usually talked about at conferences like these. Service workers are amazingly powerful, but we frequently only focus on the few things that we use them for in progressive web apps, such as serving content offline. But today, I want to talk about some powerful and potentially odd ideas that we could use them for as well. But first, before we get into all that, who am I? My name is Trent Willis, and currently I'm a senior UI engineer at Netflix. But more importantly than that is I am a person that loves the web, and I love JavaScript, and I love web development, because there's a lot of creativity and freedom to be found in this field. And that's what's really exciting to me about this conference in general, is we get to hear about so many awesome things that are developing in the world of software. And this time in particular for web development and software engineering is really exciting because of how much evolution and change is going on. JavaScript in particular is continuing to evolve a lot and at a very rapid pace. And sometimes it can feel overwhelming, but more often than not, I find myself excited by all the possibilities of what we are getting to witness. And so earlier in the year, I was looking into some new exciting web technology and discovered some interesting information. And that's what spurred the heart of this talk. So what was that information? Earlier in the year, I was looking at a specification that comes from the Web Hypertext Application Technology Working Group. Since that name is way too long, they're more commonly known as WHATWG. Anyways, I was reading their specification for the Streams API. This is a specification that aims to provide some primitives for the web platform to interact with streaming data. Now, if you've worked in Node.js at all, you might be familiar with streams as they're relatively common there. But up until recently, there was no primitive for that on the web until the specification came along and started shipping in some browsers. What was really interesting about this specification, though, is that in the introduction for it, they identify this use case. If a stream is installed inside the fetch hook of a service worker, it would allow developers to transparently polyfill new image formats. And this got me thinking, that's pretty awesome. I had never considered using service workers for something like that. I had never considered using them for something outside of standard progressive web app functionality. But I came to realize that, hey, if we could use this to polyfill image formats, we could probably do it for basically any type of file. Beyond just images, you could polyfill new video formats, new audio encodings, or maybe even types of code to execute in the browser. But I'm getting a little bit ahead of myself with all this. What is the theory, or how is this actually possible with service workers? If we have a new file format, say a new image format that we want to support, if we were to polyfill this in the browser, it would mean that we want to use it in a way that is intuitive, how we would use another image. So normally we would use an image tag like this to load up an image in our web app. And if we wanted to do it with a .nif image, we know that this wouldn't work because the browser can only display PNGs, JPEGs, GIFs, and other formats that it understands. And so how would we get this to work? Well, the answer is to insert a service worker. Most of us are aware that service workers are useful for delivering content offline and enabling push notifications and add to home screen functionality. But a lot of us don't think of them as a proxy or a middleman for all the requests that are going to our application's server and its CDN. And when we think of them in this light, it becomes a lot easier to understand how we might polyfill a new file format. And we do it by simply taking the response and as it passes through the service worker, transforming it into something that the browser can understand. So that's the high-level idea here. But how can we actually do this? Before diving into the code, I want to mention that all of this is going to be available online. So don't stress about taking notes or getting down every little detail. There is going to be plenty of links to demos that you can follow, and I will be tweeting out some slides that you can go look at later as well. Now let's get to polyfilling. So we'll start by registering a service worker. We do this using the standard navigator.serviceworker.register function, and we give it the file of our service worker. I like to be explicit with my naming, so I simply name it service-worker.js. Now in that file, there are two concepts we need to know. The first is known as the fetch event. And so a fetch event is simply a JavaScript event that gets emitted anytime a request is made from a page where a service worker is active. This doesn't just happen for JavaScript-initiated requests like XHRs or fetch requests, but for anything, including the initial load of your page, as well as image and other assets that get loaded by the markup. This event contains a whole lot of information about what is happening in the request, such as what URL it's for, what its destination is in the page, and so forth. But that by itself doesn't do a whole lot for us, right? We don't want to just see the events that are happening. We want to actually do something with them. So the second API that we need to be familiar with is the respond with method. And this is a method that is on the fetch event object. And it simply allows us to say, hey, instead of responding with the normal network response for this event, respond with this other thing instead. And so this is really exciting because this is how we enable offline apps, right? We say, hey, instead of responding with the network response, take this other value that I have in the cache and respond with that instead. But if we take that idea and expand it, we can use it for so much more. And so in our case, we're going to generate another response with a function that converts our polyfilled file format into something that's valid for the browser to understand. And then obviously, we'll want to guard this in an if statement, so that way we are only doing this for requests that actually need that polyfill and not for all of them. Now, if we look at this method, how do we generate a valid file from a polyfilled file? There is a general structure that I like to follow. And it looks more or less like this usually. We start by actually fetching the original request because we need the original data. Next, we access the data from the response of that request. Usually, you can do this with .json if you're dealing with JSON data, but there's also .blob, .text, .array buffer, a whole bunch of different methods for accessing that data. Next, you take that data and transform it using whatever transform method you have defined. And then finally, you construct a new response object. And you simply return that back to the event's respond with method. And that's it. That is the high-level idea. And this is basically all of the actual service worker code you need other than your transform function. So here's a quick demo of this actually running in a browser. So as you can see right now, we're loading up a new image format, but it's not working because we get a broken image. But if we enable the service worker, voila, it works. And you can find this demo online at cryptogram-naive.glitch.me. So definitely check it out at some point because there's a lot of stuff that goes on in this demo that I didn't talk about today, purely because of time constraints. But we can do more than just images with this. Right? What if we think about extending the actual web platform itself? So in this demo, I've put together a polyfill that allows us to actually load HTML code into our JavaScript modules. So we have some markup in an HTML file, And then in our JavaScript, we can actually import that .html file. And in our browser, we can actually use this. And it runs. It works fine. The ability to polyfill image formats, other types of file formats, is really going to open up a whole new area for us to be creative in and experiment with pushing the browser forward. And that's something that really personally excites me. But what else could we do? Well, we could actually expand this technique, think even more broadly, and apply it to all kinds of code. We could compile any sort of code that we want at runtime in the browser. Now, this might not be a good idea to do in production, but for experiments and for prototyping, it can be really exciting, especially if you are working on something like a TypeScript application. Now, again, I would not recommend doing this in production, but what about for your development environment? Right, what if you could test out your TypeScript code in the browser without needing to set up a build and a watching system, and you were able to just load it up into your browser? What if you could load it like this? Or even using the new ES module syntax like this? It would be really awesome to experiment with TypeScript code in this way. Because I don't know about you all, but I hate setting up build systems. I like to just create files and load my browser. However, there's a catch to all of this, right? If you're working on an application like this, it's likely going to be slow if you're compiling every single file every single time that you load up your web page. So we need to leverage another API that service workers have brought to us, and that is the Caches API. And the Caches API is actually available to us both in a service worker as well as on the main thread. So you could find other creative ways to use this outside of service workers. But basically, the idea here is we only want to compile the files that we've changed. And the Caches API gives us a very convenient way to do this. So let's say we have a function that's running in our service worker. We're going to call it compile with cache. And it's going to take in a response that we're getting for our code, and a function that we're going to use to compile it. Normally, we would use just the TypeScript compile function. And the first thing that we're going to want to do is take the global caches object, which represents the cache storage API that service workers have, and open up a new cache with a name. You namespace your caches so that way you don't potentially get conflicts with other caching that's going on. Once we've opened that cache, we want to check to see if the file that we're loading, the response that we're getting, if its status is a 304. That simply means that the file hasn't changed since the last time we loaded it, which means that we should have a compiled version of it in our cache. If that's the case, we're going to call cache.match and find an entry in the cache that matches the request's URL. Oh, apologies, that's a typo. That should say response URL. And the reason we do this is because the Caches API is actually specifically geared towards storing request and response values. And so you store a response object in it, and you can then look it up by either a request object that has a matching URL or just giving it a URL specifically. In the case that we don't have a match in the cache, or our status is not a 304, which means the file has changed, we want to compile it. We'll then put that response into the cache. And note, here we're calling clone on our compiled response. And the reason for this is the browser can only use a response object for one thing. And so in order for us to both put it into our cache as well as return it to the browser to use, we need to create a clone of it. And thankfully, the spec authors have thought far enough ahead to provide us a very convenient clone method. And then finally, we return our compiled response. And we can return this to the method that we had earlier, where we return it to respond with, and it would work. So here's a demo of this actually running in the browser. We have some very simple TypeScript code with just some simple string annotations. And we're importing this module into a web component. And it loads in the browser. And you can see that by default, we don't recompile stuff that hasn't changed. But if I go and add an extra exclamation point, voila, it compiles. And so we'll always be getting those updates without actually having to have a build process running locally. Now, you can find this online at typescript-in-browser.glitch.me. As before, Go check it out at some point. It's really exciting to me because I love TypeScript, but again, I hate working with build processes. So we've talked about polyfilling file formats, running TypeScript or other compiled code in the browser. But what else can we do with service workers? There's more that we can do here. What if we were able to process our data without it ever hitting the main thread of our application, without it ever having to actually go through the main thread of our JavaScript execution? Or rather, what if we could do it before it ever hits that thread? Traditionally, when we process data in the browser, the methodology looks like this. We make a request from our JavaScript thread to our API, and once we get the data back, we process that data on the main thread. Now, this works fine for small data sets, as we all know, but what can happen is that if you're doing a lot of heavy lifting or dealing with a very large data set, you wind up blocking that thread, which causes the browser to jank and delivers a generally unpleasant user experience. And so there's been a lot of talk recently about processing data off the main thread in things like web workers. But what about data processing for some of the use cases we just talked about, right? What about processing TypeScript code that you're loading via a script tag, or image code that you're loading via an image tag? Well, in order to do that, we need a service worker. And the reason is because service workers can deal with all requests, whether they're from your JavaScript thread or from somewhere else in your UI, such as your HTML. And instead of processing on the main thread, we're now processing in the service worker. But what happens when we wind up doing a lot of lifting in that service worker? We risk blocking the service worker itself. And so what can happen is you'll introduce a bottleneck that actually prevents any of the assets, any of the requests that you're making from your page from loading speedily because they have to sit and wait for that thread to clear up. So what if we introduced web workers into this equation? What if we actually did our processing like this? The service worker would then delegate out to a web worker so that way it doesn't block its thread of execution. This seems like a pretty great idea, in my opinion, because it solves the issues that we were previously encountering, but it comes with a catch. Service workers cannot actually create web workers. If you try to access the web worker global object inside a service worker, you will get a undefined is not a function error, which is not so great. But there is a way around it, and it's easier explained with some code than me trying to verbally tell you. And so let's dive into that. We're going to process in our web worker while making requests inside a service worker. And the idea is that we are going to use a message channel to actually communicate between the two. So let's dive in. To start, we're going to have a method called transform that runs inside our service worker. Now, as before, we are going to fetch the request, the original request data that we were going to deal with. But at the same time, we're going to get a port to a web worker from the client that is making this request. And in order to do this, we need a client ID. This client ID actually comes from the fetch event object that we were talking about earlier. And so you can find it there. And it's simply an identifier, so that way the service worker knows which client is responsible for the request. And this is needed because service workers can actually handle requests from multiple different pages simultaneously. So in order to get this port to communicate to our web worker, we're going to call clients.get with the client ID. And this will give us a reference to the actual client that the service worker is handling the request from. Next, we want to return a promise because it'll make our code easier to read rather than using callbacks. And we're going to post a message to that client. And in this case, it doesn't really matter what data we're posting. You might want to send a flag or some identifier so that way it knows what type of event it's handling. But the idea is that we want to let the client know, hey, I have received some data, and I want you to send me the port for a web worker. So on our client, we're going to have this code where we've instantiated a web worker and set up an on-message handler for our service worker. When we receive that message from our service worker, we can instantiate a new message channel. what we will then do is take that message channel and send one of the ports to the service worker and send the other port to a web worker. Now, it's understandable if this is a little confusing. The message channel API is relatively unknown to most developers because a lot of folks don't use it. It's a little bit clunky to use. But essentially what it does is it provides you two ports that have a post message method and an on message event handler. And it allows you to then communicate from one port to the other by sending messages. What's really unique about it, though, is that these objects are transferable, which means that you can actually transfer them from one execution context in your browser to another. That means you can send them from your main thread to a web worker, or to a service worker, or to a shared worker. And this is really powerful because it enables you to send data between those different isolated execution contexts. So with that message channel set up, we jump back into our service worker, and we say, hey, when you have gotten a message back, simply resolve with the port that we received. That then goes back to our transform method, and we can construct another promise to return, similar to the one that we just did. In this case, we're going to post a message to that port once we get the response from our initial request. So what this is saying is, say, hey, take the data that we got and send it over to that web worker for processing. And then when we get a message back from the port, we can simply resolve our response with that transformed data. So here's a demo of this actually working. We start off by showing what it looks like if you don't do this technique. And here we have some complex data transformation that's happening while we try to make other requests. And we're actually only able to complete 2 other requests while this is running, which is kind of unfortunate. It means we're blocking a lot of stuff that could potentially be happening. But if we use the method that I just described, we can actually complete 13 requests in that same amount of time. And at this point, really, the only limitation is based on how fast we can load those requests. So you can check out this demo online at service-worker-worker.glitch.me. And I understand that there are a few concepts in here that are relatively unfamiliar and might be a bit difficult to understand. And so I would highly encourage you to go check it out, spend some time with the code. Chances are you'll learn something. I know I definitely learned quite a bit while putting it together. So speaking of unfamiliar APIs, let's loop back to the beginning and talk about the Streams API. How can we do streaming data processing with web workers? I mean, that was kind of the initial thought that led me on this entire rabbit hole. So streaming data is pretty common on the web, right? Whether it's videos or just large JSON payloads, a lot of the ways that your servers deliver data down to the client is through a stream. But up until recently, it wasn't possible to interact directly with that stream of data on the client in an easy manner. But that's changed recently. All the techniques that we've talked about today, though, rely on this model, right? We download all of our original data first, and then we process it. And this is fine for some use cases where we're dealing with smaller data sets, but it can be really bad if we're dealing with large amounts of data where we have to keep this entire data set in memory twice while we perform this transformation. And this is effectively known as batch processing, right? Because we're waiting for all the data before processing it in one giant batch. So how do we make this better? How do we make it faster? And the answer for some use cases, not all of them, but some use cases, is to use stream processing. And this is where that Streams API comes into play. Now, if you're not familiar with stream processing, you might say, I don't really get how this would make things better. Right? We still have to download the same amount of data, and we're still going to have to do the same amount of work on that data. So let's dive into the concept a little bit. Same as before, we're going to start by downloading some of our original data. But after we've downloaded a small chunk of it, we can begin processing it. And as that processing is happening, we can continue to download more data. And we simply repeat this until we have processed the entire payload. And so the end result is that we should see a significant speed up because some of the work that we were previously doing after downloading all the data can now be done while we're downloading the data. So that's the idea. How does this actually play out in our code? Well, if we take that polyfill function that I had from the first demo and change a few lines here so that we construct a transform stream response instead of just a blobbed response, this will actually work. And so let's walk through this code because I know a good bit changed. First, same as before, we make a fetch request for the original response. Then, however, we want to construct a transform stream object. And we pass into it a transformer class. And I'll talk more about that in a second. The important thing to note, though, is that this is effectively how we will transform the data as it comes through. We can then take the body of our original response and pipe it through that transformation stream. And so this is a relatively new feature to the web platform, where the body object of a fetch request's response, that is actually a readable stream of data. And so when you pipe it through this transformation stream, you actually get back a new stream that has the resulting data from that transformation. We can then construct a new response from that and return that to our event. And we do all of this without having to add an extra await or .then to wait for the data to finish downloading. So let's talk about this transformer object real quick, though. A transformer is a convenient way to construct a transform stream that simply defines a start method, a transform method, and a flush method. All these methods can be async. They can return promises, which is very convenient when you want to do asynchronous or kind of heavy tasks. Maybe use the Web Crypto API to do some cryptographic modifications to your data. And the start method essentially just allows you to set up some state before you start processing data. It's called when the stream first begins to receive data and doesn't actually receive any data, but allows you to do some housekeeping and get things in order. The transform method then is where you actually receive data and you can process it and then enqueue it into the output so that that is what the end user will actually see. And then finally, the flush method occurs when all the data has been received by the stream, it's sent a close signal, and you need to do any final processing that you might have, or just clean up some state that you don't want lingering around. So I understand that that's a lot of high-level code. Let's see this in action again. So this is very similar to the first demo that I had. We start with a broken image because our service worker is not enabled. But if we go and enable our service worker, we can actually see as we begin processing the data for this image in a streaming fashion. Note that this is purposefully slowed down. I added a set timeout to the transform method so that you can actually see the effect of the data arriving over time. Without that timeout, this actually loads very quickly. And so this is exciting to me, right? First-class support in the browser, finally, for stream data processing. So I understand we just covered a lot of code, and there's so much more for you to understand about this, and you can find this demo online as well at cryptogram-streaming.glitch.me. But the specific details of all this code is not really the real point of this talk today. The real point of this talk, for me, is to showcase how many awesome new primitives and tools we have for developing on the web platform, for experimenting and being creative. We have a lot of tools at our disposal now. Service workers, web components, the Caches API, TypeScript even, other external tools. All of these things are going to allow us to do so much more than we ever have before. Right, so while these are a few of the ideas that we've talked about today, and things that I've been mulling over personally for the last few months, there's a lot more out there that we could do with these technologies. Whether it's service workers and streams, or WebAssembly, or new ECMAScript features, I would encourage you all to get out there and experiment. Have fun with JavaScript. It's a really fun language. And share what you've built. Go forth, fulfill Atwood's law, and build every application you could possibly think of in JavaScript, and share the results with people. Thank you.
Hello.
So,
Thank you, Trent.
any questions? Questions?
Yes. Are there any questions, folks? No questions? Sorry? Wait a second.
I think we could just look up on can I use, but I'm asking you, what is the browser support?
So unfortunately, I cannot hear.
What is the
What is
browser
the browser
support?
So it depends on the specific feature. So most of the stuff that I showed has varying levels of support across browsers. I think I'm highly confident that everything I demoed today should work in both Chrome and Firefox at least. Most of them also work in Safari, but it'll vary. Streams, for instance, don't have quite as good of support as service workers do. Service workers are currently supported in all major browsers now. So definitely, go check out the can I use table before you start trying to deploy any of these ideas in production. But the main idea is have fun. Definitely try stuff out, and eventually the browser support will get there.
Are there any more? Are there any more questions? Question over there. Hey. Oh.
Hi, what about security concern? Problem, injects, and so on.
Can you hear anything? What about security concerns?
I can hear now. Oh, OK. So security concerns. Again, it depends. Definitely use your best judgment. And the security concerns for the type of application you're working on is going to vary, right? Some of the things I talked about today, like TypeScript in your development environment, is a development environment concern, right? And your security implications there are probably going to be less than if you were deploying this to production. But for some other things, such as deploying an actual service worker to production and potentially caching sensitive data, you're going to need to tread very lightly and be careful about that. I am not a security expert. I will not claim to be one. And so definitely consult with a security expert and someone that understands the constraints and requirements of your particular business and use cases.
Any more questions? No questions. We still have some minutes. So I got some question for you. You mentioned you could use this service workers with WebAssembly to do something interesting. Any pointers, any ideas, something fun that you might want to do with WebAssembly and service workers?
So it depends. WebAssembly, in my opinion, is very exciting. I think it's going to allow us to offload a lot of code that we're currently writing in JavaScript into something that is better suited for the task. A lot of what I talked about today, for instance, regarding processing data, should ideally be offloaded to WebAssembly, right? Because WebAssembly is good at dealing with just streams of data. So one of the examples I put together, the images actually are built using the Web Cryptography API, which basically takes a cryptographic method and decodes that data as it comes down, de-encrypts it, that is. And so what's exciting to me is that you could actually start adding your own new, potentially better cryptographic methods as they're discovered without having to wait for the web platform to implement them, right? And you could do that using things like WebAssembly. And WebAssembly is also super exciting to me because you can embed it in so many different runtimes, right? It's a portable binary. And so it doesn't just have to be in the browser. Cloudflare, for instance, is starting to use a service worker-like model for some of their edge computing ideas. And so you think about combining that portability and your ability to ship it to both your client as well as potentially edge computing. And I think there's a whole really exciting world of possibilities that's going to open up for us as web developers.
Thank you, Trent. Are there any more questions? Over there.
Hi. So I use Netflix quite a bit, and especially when I'm, like, I don't know, I'm at airports or places where I cannot charge my computer, I care a lot about the battery life rather than other things. So for example, speed of execution of, I don't know, downloading an encrypted file and then decrypting it and streaming it. So I guess that here you would be actually transferring a lot of memory from the main thread to a separate thread or process or whatever it is. So about the battery and the fact that these things will tend to be limited at a certain point in time, from browsers. Do you think that it's better to have a trade-off in terms of better performances or better battery, in your opinion?
In my opinion, so I want to start off with a preface that I do not work on Netflix's main consumer application. So anything that I say related to that is not official. But in my opinion, it really depends on your use case and what your users want, right? If we find out that a large majority of users value their battery life far more than, say, performance or even the amount of videos that they could like store offline, for instance, then we would optimize for that, right? And so it's going to vary heavily depending on what your use case is, the market that you're serving, the folks that comprise that market. And so collect data, do a lot of research, and find out the best solution for your use case. I hate to fall back to this so frequently, but the answer honestly is it depends. And I will wind up saying that a lot probably.
Thank you, Trent, and thank you for coming and sharing your knowledge about Service Worker. And I think there is a lunch break or something starting up, and we'll be starting up back again in this room in like 10 minutes. So see you all in 10 minutes. So big round of applause for Trent.